Here is a question that falls under optimization, which is part of Calculus Grade 12. And here we have a question 10 that says, the diagram below shows a plan for a veranda, which is to be built onto the corner of a cottage. So if we have a look at this diagram, here is the cottage, and onto that corner, they are going to build a veranda, which is basically represented by the letters A, B, C, D, E. It says a railing ABCDE is to be constructed around the four edges of the veranda. It is given that AB is equal to DE, which is equal to X. Let's actually just fill that in since it's not on the diagram. So they mentioned that AB is equal to DE, which is equal to X. So we have X there. Let's fill it in here. AB and DE are equal, and they're both equal to X. Then they also mentioned that BC is equal to CD, which is equal to Y. So here is BC, which is equal to CD, and that's equal to Y. And the length of the railing must be 30 meters. Calculate the value of X and Y for which the veranda will have a maximum area. Now this was just one complete question for 8 marks, so they did not break it down in any way. Now for this kind of question, we need to figure out our own equation that we can use to work this out, since there's no equation given. So a good place to start would be to get the lengths all around in terms of X and Y of this veranda. Now, I want to focus on getting FA. And FA is actually going to be Y minus X. So why would it be Y minus X? You guys notice that it's a vertical length. If you look at the entire length of BC, it's Y. And if you look at the length of DE, it's X. If we take Y and we minus X, basically if we take BC and we minus DE, we'll be left with AF. So Y minus X is AF. Then let us get FE. So working horizontally, the entire length is Y and AB is X. So if we take Y and we minus AB, we'll be left with FE, which is Y minus X as well. Now that we have all of the lengths, this can allow us to get an equation that allows you to get perimeter of this shape. Since they said that the railing must be 30 meters long, if we add all of these lengths that creates the railing, we can equate it to 30. So that is our starting point. So we're going to say, adding all of these lengths, and you can actually write down the lengths, the names of the lengths. Okay, so I'll start here. AB plus BC. So I'm just going around this shape, plus CD plus DE, then it's going to be EF and FA, which also forms this shape. But here's the thing, you guys. Think about it logically. Where is the railing going to go? Since this is the cottage, railing is going to go on the outside, basically on the border of the veranda. There is not going to be any railing on EF and FA, because remember, EF and FA is the corner of the cottage, so we don't require any railing there. So when we're adding all of these values, we are not going to include EF and FA. Okay, we're just going to stop at DE and we're going to equate that to 30. The reason why we are not including FE and FA, because we don't require railing for those portions. Okay, now let's replace all of these sides with their lengths. That is going to be X plus Y plus Y plus X is equal to 30. And if we simplify the left-hand side, we have 2x plus 2y is equal to 30, we can divide throughout by 2. So we have x plus y is equal to 15. Now, in this equation, we can either make x or y the subject of the formula. So it's up to you. I think I'll go ahead and leave y as the subject. So I'll take the x over to the right, and I have 15 minus x. So I've got y as 15 minus x. Now, how does this help us to get the answer? Going back to the question, they want us to calculate the value of x and y for which the veranda will have a maximum area. For which the veranda will have a maximum area. Now, to calculate area of this shape, I'm just going to complete this rectangle. If this is the entire rectangle that we're working with, area would be quite simple for us to get because we would say length times breadth, it's y times y, which is y squared. So we understand that the area of the veranda, this is going to be the veranda. If it was a complete rectangle, it would just be y squared. However, what we notice is that we've got this shape. So this other rectangle, which is part of the cottage that is not part of the veranda. So let's do this. Let's get the area of the entire rectangle for the veranda and minus the small rectangle that's part of the cottage. So that's a good strategy. So we're going to say area, which you can represent, okay, let's just write it as area. And for the cottage, let's use corresponding colors so you understand what's happening. For the cottage, as a complete rectangle, it would be y times y, which is y squared. From that, we are going to minus the small rectangle that is part of the cottage. Okay, so for the veranda, it was y squared. From the cottage, we are going to minus the small rectangle, which is going to be y minus x times y minus x, which will give you y minus x all squared, since it's the same length being multiplied by itself. Now this can be simplified, and let's go ahead and do that. We have y squared minus, here we have a binomial squared, it's going to result in a trinomial. This is the trinomial that we get. And I'm now going to take that negative and multiply into the bracket with all three terms. It is going to change the sign of each term. Here we have y squared minus y squared. They cancel out with each other. We're just left with 2xy minus x squared. Now, how does this help us? You guys, we previously have gotten y in terms of x. Let's replace y in this equation with what it was equal to before. We had y as 15 minus x. Let's take that 2x and multiply in. We're going to get 30x minus 2x squared. Then we also have a minus x squared next to that. Gathering like terms, we have 30x minus 3x squared. So this gives us a nice equation for area in terms of x. Now we can actually do what the question wanted us to do, where they wanted maximum area. So we're going to say area prime. And remember, you guys, when it comes to questions where they ask you to get either the maximum or the minimum of something, please work as if you are calculating local maximum or local minimum by getting your first derivative, equating to 0, and solving. So area prime here is going to be 30x minus 6. Actually, 30 minus 6x. Let's now take this first derivative and equate it to 0. So we're going to have area prime equals 0. I'll actually take the minus 6 to the right so it becomes positive. Divide throughout by 6, we get x as 5 meters. So that is our first answer. Now we need to get the length of y, and if we go up, y was 15 minus x. So y is going to be 15 minus x, which is 5. Therefore, y is 10 meters. So here are the values of x and y that causes the area of this veranda to be a maximum.